Got another one here. Now, look what we're using now. A 42S. All right, we're going to use this to solve a little math problem. Ignore the top part. That was just for fun. All right, here's the problem. Box perimeter. You got two boxes, okay? Box 1, box 2. 3x3 box and a 5x5 box, and they're sitting at the position shown here. All right, kind of 0, 0, 3, 0, 3, 3, 0, 3. This one is at 8, 0, 13, 0, 13, 5, and 8, 5. So it's a 5x5 box sitting 5 whatever inches or I don't know units over from this one. Okay. Now we have 2 points. They're both starting in the upper left corner of the box at time 0 with 2 different velocities, v1 and v2, in this direction, left to right, and they're going to go around the box like this. Okay, this one starts up here, this away. Just goes, marches around the perimeter, and just keeps going. Same with that one. As soon as you say go, they both do that. Now again, they're going at different speeds. So the question is, write a program on the 42S to tell you, given those 2 different speeds and a certain time later, how far apart are those 2 points. Also store where they actually sit. Okay. All right, so what you got to do is you got to find the position of the first point. We're going to call that A and B, and the second point, we'll call it C and D. And then the distance is just going to be the Euclidean distance between the two. Square root of the x deltas squared plus the y delta squared of those. So it's just a triangle once you figure out where they're at. The interesting part is figuring out where they're at. Now here's what you're going to do. You're going to find the percent of the way around the perimeters they are at that given point. Okay, so you're going to take the total distance of the perimeter of each of these boxes, okay, which you can easily figure out. This one's just 12, this one's 20. And then you're going to divide that. Divide by, yeah. What you got to do is you got to find, at the time that you stop the clock, given the velocity, where are they as a percent of the perimeter? So let's say it's like they've gone 5.5 perimeters. All you care about is the fractional part of that, the 0.5, okay? Because all you're going to do is say, well, it's halfway around. It doesn't matter that they went 5 times around, it's just where are they right now when I stop. Okay, now this is kind of fun because you get to use some branching, because there's really 4 segments that matter when you do the calculation. Since these are squares, if it's 0 to 0.25% of the way, or 25% of the way around, it'll be on this leg. If it's 25 to 50% of the way around, it'll be on this leg. 50 to 75, it'll be on this leg. 75 to 100, it'll be over on this leg. Same with that box. So you're going to break it down into those 4 ranges. Again, for both boxes, because they both have different perimeters, different velocities, so they'll be at different positions as a percent of the way around. You figure out which leg they're on, and then you can plug in the math for that. So as an example, on box 1, if it's on that first leg up here, less than 25% of the way around, then the A, which is the x value, is going to be the fractional part divided by 0.25. So the fractional part might be like 0.15. Okay, so it'll be 0.15 over 0.25, which is a ratio in 0 to 100% of the way that it is across that leg, times 3, which is the length of the leg. Okay, that's going to give you the x value for that. And then over here, if it's 50 to 75%, so it'd be 25, 50. Over here, if it's on this, then 50, 75, 25, 50. Oh, I'm sorry, down this one. 0 to 25, 25 to 50, 50 to 75 over here. It's going to be going in the opposite direction, remember. So it's going to be 3 minus the fractional part minus 0.5, because you got to get it down to either 0 to 25. Divide that by 0.25. So again, that's going to give you the percent of the way across the 3 length of that leg it is. And it's 3 minus that. So it's going to be pushing it to the left, 0% of the way, 50% of the way, 100% of the way over in that range. So you're doing that kind of algorithm for both boxes, and you got 4 cases for each of the boxes. All right. Sorry about that. Just trying to make sure you're awake. Okay, now here's the program. Well, more of the math, I guess. So this is the B and the C and the D, and the logic for each of those. And then we start the program. It's kind of a long one. Take a screenshot of that. That's the first page. Again, top to bottom, left to right. There's the next page. Okay. And again, the algorithm is pretty straightforward here. You're just breaking the box into 4 positions, finding the A, B, C, and D value, depending on how far across it is. And that's the end of the program there. And there's an example here. Let's go ahead and run this example. And the entry is pretty simple. It's just V1 enter, V2 enter, time, and then execute. So we're going to do V1, in this case 1.5 feet per second, enter. V2 3.6 feet per second, and we're going to wait 13 seconds. Execute boxes. Pretty quick. 11.9369 inches apart. And everything's in the registers. So A, B, C, and D, you can see, you can just recall them. A is recall 10, B is recall 11, C is recall 12, D is recall 13. I've already done that in the other example, so you can verify this all. So A and B on that first box, the point is at 1.5 and 0. The point of the second box is 13 and 13.2. And there's the fractional portion of the way around on box 1, about 6.625. Box 2, about 0.34. All right. Kind of fun. Thought that was kind of an interesting little program. Once again, the math is smarter than both of us.